Hi, my name is Lauren Robertson and I will be presenting Unit 19, Human Immunity. This presentation will be divided into three sections. Firstly, defining non-specific defences against disease surrounding the topics of infection, inflammation, fever and the role of macrophages. Secondly, the immunity and sensitivity to antigens, immune cells and immunoglobulins, with the inclusions of disorders such as lupus and dermatographia, followed by the recognition and tolerance to own tissues as well as the rejection of transplanted organs. Thirdly, the biology behind vaccinations in the areas of acquired immunity, including natural, artificial, passive and active immunity, with the explanation on the immune responses to vaccination, including immunological memory and the inclusion of the evaluation on herd immunity, vaccination programs, factors affecting vaccine uptake and the benefits of vaccination. Let's get started. The immune system is a microscopic army that offers protection against potentially harmful toxins, infections and diseases. It consists of cells, organs, proteins, tissues and the lymphatic system. Immune cells travel through blood carrying the right antibody to the place of infection to repair and clear the area. Infections are caused by pathogens, which are an infectious agents that brings potential harm to the human body. They are diverse, meaning they come in many forms under the four main categories. Bacteria is a microbe that comes in good and bad forms. Good bacteria lines the gastrointestinal tract, functioning as a barrier for protection against harmful bacteria that is digested through food. Bad bacteria can cause illness, sickness and potential harm from the inside, such as E. coli, strep throat, MRSA, food poisoning and other gastroinfections. Viruses, they cause various deadly illnesses such as COVID-19, Ebola, smallpox, HIV or rabies. On the other hand, there are some viruses that the body can handle, such as the common cold and viral infections. Fungal infections or mycosis can differ from gout to vaginal candidiasis. These types of infections arrive from the moist and dark areas, places that the sun or hygiene can't quite reach, commonly affecting the finger or toenails. Parasitic worms or health mints are living organisms that take over the gastrointestinal tract, attaching to the body, thriving of the organs in the digestive system. They are very common in adults, mainly tape, flat or ringworms, which are a result of eating undercooked meat, ingesting something from an animal. These larvae are minuscule and cause disease. There are multiple methods of transmission: direct contact, indirect contact, insect bites, and food contamination. Immunity is divided into two specific defense systems: non-specific innate immunity and specific acquired immunity. In this section, I will investigate non-specific innate immunity, function, structure, and detailed components. Non-specific innate immunity is developed from perinatal and neonatal stages of life. This immunity is shared and passed along from the mother's own immune system. Innate immunity tackles the equal elimination of microagent at a rapid response. This is down to the innate cells having no memory, eliminating any harmful germs that enter the body. The innate immune system consists of first and second line of defences. They are an accumulation of external and internal defences in the form of physical, chemical and cellular barriers, all in place to defend the body from pathogens. Physical barriers such as the skin and mucous membranes are primarily considered the first line of defences. The skin is the external barrier that stops all harmful cells from entering the body. This coat of armour prevents any pathogens from reaching the healthy tissue that is prone to infection. It is formed of three layers: the epidermis, dermis and hypodermis. Epidermis produces an epithelial cell layer that contains sebaceous oils such as keratin, along with the secretion of fatty acids known as oleic acid. This kills specific bacteria and prevents a pathogen from going any further and causing infection. Keratin also enables the skin to become water resistant, stopping any bacterial enzyme from entering and growing on the surface. Dermis is a thick layer that consists of nerves, vessels, and hair follicles that protect the skin glands from pathogen invasion. The glands produce sweat filled with enzymes known as lysine. These enzymes can break down the wall of specific bacteria, diminishing the pathogen. Sweat also produces salt and allows the washing away of any pathogens on the epidermis layer. Hypodermis is the fatty layer that holds the blood lymph vessels. This is the deep tissue that the dermis and epidermis are protecting. This is the direct entrance for potential disease entering the bloodstream. Mucous membranes is the largest internal first line of defence, covering 80% of the human body. It has many areas of coverage, essentially protecting any entrance that the skin doesn't already cover, such as the mouth, nose, ears, eyes, urine tract, respiratory openings, and the gastrointestinal tract with the inclusion of the stomach organ. Mucus comes in the form of a thick jelly-like substance known as phlegm. Phlegm is laced with protective antibodies, and it has the ability to surround any harmful germs that get past the skin and disposed of through an exit hole on the body, through either a cough reflex or the expulsion of infection. Other examples, such as cilia, which are tiny organelle hairs that lay inside of the respiratory airways. The eyes contain tear ducts that produce liquid that isn't just water. Like the skin, it also contains lysine, which breaks down some bacteria. This natural cleanse eliminates the entrance of potentially harmful microbes, washing out anything that encounters the eye. The mouth has a lining of mucosa. The nose and ears accumulate earwax and dust buildup, along with tiny hairs that serve as a block at the entry points of the respiratory airways. Stomach and gastric acid is highly acidic pancreatic juice that lays in the stomach organ. It dissolves any pathogens that manage to be digested through food. The genitourinary tract enables the flush out of any unwanted visitors through urine. There are also other levels of mucosal protection, specifically in females. The vagina produces lactobacilli to keep replenishing the cleanliness of the womb. This enables the disregard of potential germs sticking and growing to the vagina. If there is pathogens that can get past the first line of defence, for example through a cut in your skin, then the infection develops. The second line of defence becomes active through a sequence of steps called the immune response. This defence consists of cells such as phagocytic leukocytes and antimicrobial proteins that work together in the innate immune system to fight the internal infection that has occurred. Once the site has actively been broken, inflammatory response takes place, along with fever, which raises the heat in the body to enable the cells to work faster. Phagocytes, such as macrophages, have an important role of secreting pro-inflammatory, immune modulation, and then leading to apoptosis, known as phagocytosis, meaning they produce cytokines to increase inflammatory response, engulf the intruder, and then are alerted with death signals to shut down, causing cellular death, eliminating themselves and the pathogen. Dying cells communicate through signals called damps, allowing each cell to know how and what to eliminate, essentially clearing the cellular debris. Specific acquired immunity is the third line of defence. It develops throughout a person's lifespan, evolving daily, fighting off all cellular dangers, by creating a barrier of immune cells to protect the sterile part of the body. The acquired immunity targets specific foreign bodies over a long period due to the memory of past pathogens. The lymphocytes, white blood cells, go in search of a specific antibody that can fight off an antigen. This can be anything from the outside environment that the body doesn't recognise, such as chemical, bacteria, and viruses. It is a very intricate process that could take hours, days, or even weeks. In the body, there are 5 types of immune cells, which are all categorised in either the innate or adaptive immune system: lymphocytes, monocyte and macrophages, basophils, neutrophils, and eosinophils. All these immune cells are white blood cells, and they have a specific job within the immune system to enable the ability to defend healthy tissue. The main immune system immune cells, lymphocytes and monocytes, include B cells that secrete antibodies, They specify an antigen-mediated immunity by binding and destroying the antigen. They're produced in the bone marrow, and they also come in two types, plasma and memory B cells. T cells are immune and suppression cells. They specify in antigens such as cancer. They also produce memory T cells, cytotoxic T cells, helper T cells, and suppressor T cells. Natural killer cells kill cells by inhibitory receptors that recognize the major histocompatibility complex, MHC, meaning that the receptors must recognize the self molecules that appear on the outside of the class I proteins. Otherwise, it will eliminate the cell that it doesn't recognize. Antigens are composed of proteins, peptides, and polysaccharides. Any foreign invaders, such as bacteria and viruses, chemicals, toxins, and pollens, can be antigens. However, sometimes under pathological conditions, normal cellular proteins become self-antigens. Based on the origins, antigens are two types, such as self-antigens are the body's own antigens, and non-self-antigens are the outside intruders that enter the body. Sensitivity such as non-self-antigens come in the form of allergies. This can be minor, moderate, or severe. Allergies such as food, pollen, dust, mould, chemicals, or toxins causes asthma, hay fever, eczema, and allergies to food such as lactose intolerance, gluten intolerance, peanut allergies, and so on. Symptoms come due to the rejection of numerous factors. Minor symptoms such as coughing, wheezing, and nausea. Moderate symptoms, hypersensitivity to the skin, sickness, diarrhea, vomiting, and rashes. And severe symptoms such as anaphylactic shock and closing of the throat that could lead to death. Immunoglobulins, known as antibodies, are a protein formed of the B cell. It is a Y-shaped structure that can neutralize pathogenic bacteria and viruses. It targets specific antigen plasma, which is located inside the pathogen cell. At each tip of the Y structure contains a unique shape called a paratope or an epitope. This function allows the antibodies to use shaped connection, described as the lock and key system, giving direct skill to neutralize and bind the specific antigen. Antibodies come in 5 classes. I'm going to highlight 2 that are most relevant to this topic. IgA, found in mucosal areas, preventing colonization of pathogens in the stomach, saliva, tears, breast milk, respiratory system, and the urogenital tract. IgG provides most of the antibody-based immunity against invading pathogens. Only antibody capable of crossing the placenta to give passive immunity to the fetus. The immune tolerance to own tissues is known as self-tolerance, meaning the body tissues that are recognized are in fact the organism's own. Tolerance is split into 2. Central tolerance encompasses the mechanisms that render newly developing lymphocytes in the primary lymphoid organs, developing B cells and T cells that react strongly to self-antigens, either undergo alteration of their antigen receptors and face functional inactivation. Peripheral tolerance is the suppression of T and B cells that can potentially promote autoimmune diseases. Antibodies and antigen proteins contribute to the function of red blood cells, white blood cells, and platelets in the blood. Blood is different from person to person, and an individual is either negative, positive, AB or O blood group. So when it comes to the transplanted organs, it's crucial to match the blood type as closely as possible. This simply is because if the antigens don't align with the original blood flow, the antibodies will reject it completely, responding in one of 3 categories. Hyperacute is immediate organ rejection. Acute, a few weeks after implantation rejection. Chronic, a few years after the implantation rejection, then becomes rejected. Autoimmune disorders such as lupus is a serious disease that attacks individuals' own tissues. This chronic immune disease causes pain, inflammation to most parts of the body, creating a butterfly rash across the face, fatigue, heart and kidney problems, arthritis, and headaches and hair loss. Lupus mostly affects women rather than men. This is down to scientific theory of low estrogen hormone levels. Another example is dermographia, with the technical translation means to write on the skin. The formation of the reaction from an autoimmune disorder such as lupus, rheumatoid arthritis, Sjögren's syndrome, hypothyroid, pregnancy or allergic reaction. The concept has been relayed as a systematic infection that releases the antihistamines from the mast cells, causing hypersensitivity to the skin. It's a common condition affecting 2 to 5% of the population, and there is no treatment. Acquired immunity develops through an individual's lifetime from either exposure to an infection, disease, passed on from another person, or a vaccine. This allows the body to fight a specific virus, enabling production of new antibodies to fight it off. Acquired immunity is divided into active and passive immunity. We're going to investigate the differences and functions that make them natural or artificial. Active immunity is the immunity that develops after being exposed to an infection or from getting the vaccine. It comes in either a breakdown of natural, which is the antibodies made up after exposure to the infection, or artificial, where the antibodies made up after the vaccination. Passive immunity is the immunity you acquired from somebody else. The natural breakdown is the antibodies transmitted from mother to baby, or the artificial antibodies required from the immune serum from the medicine. Antibodies in the acquired immunity can hold specific immunological memory to be able to fight off the infectious pathogen. This means that when a person gets sick, the body already has experienced this type of pathogen. Immune cell signals can trigger the right response. In respect to vaccinations, a vaccine holds in the variation of infection that the antibody can fight against, keeping a memory of the foreign microbe to give a rapid response of the body if the body becomes infected again. Herd immunity, also known as community immunity or group protection, is the concept of maintaining the spread of life-threatening viruses by enabling everyone in the community to become immune. Whilst there's some individuals that have the vaccine, there's also some that show hesitancy, such as anti-vax movement, religious beliefs, or the conspiracy theorist. This is purely down to the perception of each person that withholds the right of what goes in their body. Factors such as skepticism from past vaccines, like the MMR vaccine allegedly causing autism in children, other autoimmune diseases, and the re-established past infections such as measles. On the other hand, prevention and protection on this scale is only achieved through vaccination. For example, COVID-19 was the most recent pandemic that required the lockdown of an unknown virus. With the vaccine rollout and other drastic measures in place, the spread of the virus was slowed down and eventually created a high percentage of the population to become immune. Another example, in 1940, the first mass vaccine rollout was distributed for diphtheria. It is a fatal infection that targets young children. In previous centuries, it has taken countless lives, but in the 40s, the infection rate had risen up to 60,000 cases and 4,000 deaths a year. From then on, the routine immunisation programme was introduced from 1942. These vaccinations start from 8 weeks old right up to 14 years old in more recent adjustments. This important infection prevention programme maintains the spread of multiple infections that could potentially cause death in young children, such as polio, whooping cough, tetanus, measles, mumps, rubella, hepatitis B, and influenza B. The important vaccination programme has undeniable effects, with statistics of 95% effectiveness. The benefits of being vaccinated goes beyond our own immunity. It enables certain antibodies to be passed on for generations to come. This creates a strong immune system in newborn babies, children, and eventually the elderly, maintaining infection rate, eventually phasing out certain fatal viruses, infections, and disease. That was Unit 19, Human Immunity. Thank you for listening.